So in this video we have a logarithmic function and we want to find the inverse function. Now I'll point out to you that every function will have an inverse, but if the function is not one-to-one, it will not have an inverse function. It'll still have an inverse, but it'll be a relation, won't be a function. A logarithmic function is one-to-one, so there's no problem. The inverse will be a function. Now I want to start with a basic example first, so the steps are clear. So normally you're given, in this case we have a linear function. This could be a y and this will be a y. And a line or linear function that has a positive slope or negative slope will be one-to-one, so there's no problem here. But here are the steps. Let's suppose we have, here I give you the inverse, but let's suppose we have this function here. We want to get this inverse right here. Basically what we have then, if you have an ordered pair xy, and this ordered pair say belongs to some function f, this will be true if and only if the reverse of this, or the ordered pair yx, is on the graph of the what we call the inverse. And we denote that by f to the negative 1. And that's read f inverse. So in other words, if you could list all the ordered pairs of a function, and of course you can't because it's infinite, especially if you're looking at the entirety of the graph. But if you could list all the ordered pairs, you reverse those ordered pairs, that would generate the inverse. So what we do is we simply take, okay, normally we rename this a y, and we say interchange the x and the y. That has the effect of reversing the ordered pair. So where you have a y, you put an x. Okay, put a x there, and where you have an x, you put a y. So there's an x there, put a y. That has the effect of reversing the ordered pairs. So if you want to find the inverse of a function, interchange x with y, and then just solve for y. So here I'm just going to solve it for y. So bring the 6 over to this side, or add minus 6 to both sides. We get a minus 6 here. And then divide both sides by 2. So the inverse is y is equal to x minus 6 over 2, which is what is this here. And then we just rename the y. In this case it would be g of x over here, and then the inverse would be g inverse of x. That's the way you do it. Now notice, if I pick x to be 0, I get a 6. If the x is 0, the y value is 6. That ordered pair is on the graph of this function here. Notice if I reverse that ordered pair, 6, 0, that's on the graph of the inverse. Put 6 there, 6 minus 6 is 0, divided by 2 is 0. Let's suppose I replace the x by 3. Put 3 where the x is, that's 3 times 2 is 6, and 6 is 12. That ordered pair is on the graph of g. And if I reverse that ordered pair, it's going to be in the graph of the inverse, this one over here. So let's reverse the ordered pair. 12, 3. Should be on that graph. Let's check it. Put a 12 where the x is. 12 minus 6 is 6. Divided by 2 is 3. Checks out. So now let's look at the function here. Now I'm going to start out by calling this f of x just easier to work with a y here instead of the f of x. So put a y there. And then the procedure is to interchange the x and the y. So where I have a y, I put an x. So I get x. Where I have an x, I put a y. So this would be the log to base 2 of y minus 2. Okay, again, interchanging the x and the y has the effect of reversing the ordered pairs. And that is the inverse, except we want to find it in the proper form. So we want to solve it, except let's just solve this for y. So let's just minus 1 to both sides, puts it over here, and minus 1 from this will just give me the log to base 2 of y minus 2. Then we want to solve this for y. This is your logarithmic form. So let's write in the exponential form then. Definition of log n will mean that this expression right here, y minus 2, should equal to this base right here, taken to whatever power we have. So that's x minus 1, so that's the exponent. That becomes the exponent. And then I add a 2 to both sides here. So on the right side, that I just remove the y, minus 2, and a 2 will give me 0 there for this one. This will cancel, give me a y. 2 through the x minus 1. And then we add 2 here to both sides here. Of course, on this side, the 2 cancels out. I get y is equal to 2 to the x minus 1 plus 2. And then I just rename the y. If it's f, you give the answer with f inverse, or if it's g, and you find the inverse of that function, it'll be g inverse. So here I just write that. I put it on this side, so it's going to be f inverse of x will equal to 2 to the x minus 1 plus 2. And this is the inverse function of the given logarithmic function. So keep in mind that when you have a logarithmic function, the inverse of a log function is always an exponential function, and vice versa. The inverse of an exponential function is a logarithmic function. Thanks for watching. We'll see you next time.